Yeah, hi everybody, welcome back to our course. So in this course, that means in this session, we are going to discuss about embedded C programming. So in the previous lectures, I already showed you like what is embedded system. We have done like we discussed what is embedded system and what's the application of embedded system, right? And even we understood what you mean by microcontrollers and microprocessors. So I hope all these concepts are concrete in your mind. So now we are actually going to learn more about the software. Okay. So we focused like in the previous session, we were focusing on the hardware side, and right now we are actually getting into the actual stuff what we are going to cover like in this course, that is embedded C programming. And I hope all at least you are familiar with the normal C programming, the basic syntax. Okay, so like at least you are familiar with the functions, concept, arrays, and all. Okay, so with this point of view, I'm just starting embedded C programming, and even we have done little bit discussion about what is a normal C program and what is embedded C program. So nothing different, like majorly it's similar like about the software and the way we are writing. Okay, it is almost similar. Only the thing is that embedded C programming, like that we will be writing the C program for a particular hardware. Okay, so instead of the x86 processor. All right, so even the hardware can be different. So depend on the application, which controller you are using, accordingly, like we will be writing C program for that particular hardware. So this hardware details also will be included in the code, whatever we are writing. So that become embedded C programming. Okay. So I hope that's clear. And let's get into more concept. What is embedded C programming here? Right. So let's see why we are choosing like embedded C. Okay, so most familiarly you will be like learning whenever you are like hearing this term embedded system. Most probably everybody like to use the term embedded C, and nowadays of course embedded C++. Right, and let's see why this language is so popular and why people or developers prefer to use C language. As usual, C is a very basic fundamental language, and most of us, like even we started programming, that means we are coming to the programming by learning C or C++, right? So it's a very familiar language. So that is first of all, that's one reason, and it's a very basic language. Okay, so many updations happened in the newer versions and all, but C is a fundamental language and it's concrete. Okay, it's a properly structured language. It's easy to learn. So many reasons are there why we are choosing C program to the embedded industry. Okay, so let's see what exactly we are doing when we are writing a program for embedded system. For example, we are writing the program in C or any other high level programming language we are writing. And basically, finally, we are going to convert this into a machine code, right? So converting this to machine code, and this machine code, as I told before, this will be dumping to the particular hardware or the microcontroller. And the C programming language that is very popular, that the reason is that wide range of application like used, that means wide range of application we are using embedded system, and this embedded system application we are actually done using C programming language. The reason I am coming to that reasons, right? So embedded C programming language uses the same syntax and semantics of the normal C programming language, like the main function, declaration of the data type, what is the defining the variables and loops, functions, statements, structures, union. Okay, so all these concepts are going to be same, but we are actually writing this code for a particular hardware. That's it. And apart from that, I would like to discuss the extension of embedded C from the standard C programming language, that will be including the input-output hardware addressing. Okay, so fixed point arithmetic operators, accessing the address space. So these are some extra features we are going to add with the normal C program, like whenever we are doing the embedded C. That reason I think all are clear. Here we are talking more about the hardware. Okay. So that is like the little bit introduction about embedded C programming. Yeah. So now, whenever you are designing an embedded system, that means whenever you are actually having a plan to create a product, right? So you are actually invented, or you got some idea and you got some problem. Just to solve the problem as an engineer, so what usually will think, we have to make some solution, right? We have to make some product. So in the product, of course, hardware and software, that's the mandatory parts over there, right? Suppose if you choose the hardware, everything is done, everything is perfect, and you designed everything, the electronic circuit or the electrical circuit, okay, or the mechanical movements or the mechanical circuits, whatever it is required. So we cut it. Yeah, so like the mechanical things, whatever it is required, Right. So, I'll try to repeat it. Okay. So whenever actually we are planning to design a product, okay, so we'll be focusing on the hardware side and the software side, right? So in the hardware side, we will be designing which microcontroller we want to use, or what are the other supported peripherals. Okay, so what we are going to use over there, or the electrical circuit or the mechanical designs, whatever it is required, we'll be planning that. Maybe that's the initial stage, right? So then after that, we'll be thinking about the software. Why we need software if you want to develop a product? The reason is that if you have all this hardware, somebody there, like somebody should be there to control all this, right? So as I told already, this controlling will be done as per the program you are writing. So you are actually the instructor, or you are the person who is actually going to take the decision. So you will take all the decision, you will plan everything, and you will write this plan in a programming language. It can be anything, C, C++, whatever it is, and that you are actually feeding to the machine code. I think that even clear, right? Okay, so I told already how better you are actually taking decisions. Accordingly, you will be able to address all the problems, okay, or address all the aspects, and you will be able to write a proper code. Yeah, now let's see, before selecting the software, before selecting the programming language, we have to like go through certain things, certain criterias. We have just want to look at certain criterias. Accordingly, I can choose the languages. I think most of us are comfortable with multiple programming languages, right? Then now let's see how we are going to choose a language for this particular hardware. So that's what we are going to discuss. First of all, we know like embedded system always will be having very limited resources. Not always, but I am thinking at least with the like with your laptop, that means with your PC, if you are comparing, embedded controllers will be having limited resources like memory, okay, so the peripherals, everything, so that is limited. So that is important thing that we'll be considering. And second thing about the product size, we know, right, the like simple pacemaker or the remote can't be the size of the laptop. Okay, so we'll be checking about the size. Okay, so size, the physical size also, and the code size also. Why we are like thinking about the code size? We know the memory. Okay, if the memory is limited, the kind of code whatever I am writing, so that should be limited. So that is important. Like in embedded device, whenever you are choosing the programming language for embedded device, size of the program is very, very important. Right, you can see the memory that the program occupies is very important. Like as embedded processors like microcontrollers, they have very limited amount of room. Okay, read-only memory or the program memory or flash memory, that's very limited. Okay, so we'll be like considering this aspect at the like at first. Then apart from that, the speed. Okay, the program must be very fast. They must run as fast as possible. The hardware should not be slowed down due to the slow running software. That's very important thing. Okay, anyway, we know like in embedded devices, the controllers, the kind of controllers we are using, they are high speed. Of course, the frequency and all we already discussed. Okay, but anyway, that can't be high speed compared to the PC. Okay, so sometime it can be, that depend on the controller whatever you are using. So like the hardware, anyway, it will take some time. For example, the sensor to sense some physical data, it will take some time. Okay, let it be. So that we can't, up to some extent we can control it. Okay, so maybe you can actually like improve your sensor design and all. Okay, whatever it is. But on the other hand, the software, right? The software shouldn't delay. The software shouldn't like make any problem, like while reading the sensor data and displaying that. One simple example I would like to share here. Suppose using a temperature sensor, you are reading the physical. Okay, so the normal room temperature. So like you kept as a normal temperature sensor. So in this temperature sensor, it will take some time, right? At least it will take some time, even for 1 degree like change in temperature, not even 1 degree, 0.1 degree centigrade change, it will take some time. Okay. So if you are measuring the normal room temperature, that is fine, that is okay. But the kind of controller or the kind of program which we are having, so that shouldn't delay like while sensing the temperature, that means while reading the temperature, converting that to digital. Okay, so maybe if you want to display that in an LCD, okay. So like as a software part, you shouldn't delay this process. You have like you shouldn't delay. Maybe the sensor, even though it is slow, that's fine. Okay. Yeah, that even depend on the application. So like maybe measuring the room temperature a little bit slow, that is okay. But in some industrial applications, if the temperature is very crucial thing, so even maybe 0.1 degree change in centigrade, and you are actually like using a software that is delaying the measurement. Okay, so maybe something can happen. So that's why we have to be very careful about the speed. Okay, so speed should be the like motto. We have to consider that like the software, because of the software, it shouldn't like slow down the device, and it shouldn't actually like maybe because of the slow software, it shouldn't actually speed down any devices. So this thing we have to be careful. Okay, and the next thing is about the portability. We know, like even I think I discussed earlier, like maybe whenever we started writing embedded programming, we were actually behind assembly language. Okay, so we were using assembly language programming just to write a software for any microcontroller. Okay, why it's so? Because we know the microcontroller, maybe the basic controller like 8051, like any AVR series or pick IC, whenever we are using, like usually the developers or the scientists, they will be actually going through the data sheet. Okay, so they will be checking the data sheet, and they will be actually going through the instruction set. Okay, so they usually will learn all the instructions. Okay, so many instructions can be there. 200 or 500 plus instructions will be there. They will actually get into that. They will understand that particular instructions, like they already done, the manufacturer already designed maybe with the architecture. So accordingly, they used to go with the instruction set, and then they will be writing the program. This is okay. We are actually getting more into the hardware. We are actually connected more to the hardware. The problem is that this is not portable. Suppose I learned 8051 instruction set. Okay, so maybe when I started with 8051 controller, then I learned the instruction set for 8051. I have done maybe a couple of programs over there. Okay, then when I am coming to the ARM programming, with those instructions, of course, I can't work with the ARM controller. Why? Because both are different machines, right? So that's an 8-bit machine. So the register size will be 8-bit. Okay, 8-bit or 16-bit. And ARM controller is a 32-bit controller. So the instructions itself will be different. Okay, the registers can be different. And the way we are programming can be different. Okay, so that's why I'm telling the assembly language, if you are using, that is not portable, right? But on the other hand, we know, like whether you are writing the program in C. Okay, so C program, as we discussed already, the C program you are writing for host machines, right? Even if you are using different operating system, different compilers, almost the C program is similar, right? If you written a C program, like whether you are using any online compiler or if you are using any IDE, almost it's similar. So that's the reason we are discussing that the portability is an important factor when we are choosing any language for the embedded system, especially because we know, right, we are actually going to work with different controllers, that mean different hardware. So there should be a language which is actually comfortable with different hardware. Yeah, the next thing is about the ease of implementation, ease of maintenance, okay, readability. So like normally a C program, at least somebody having like a little bit knowledge, okay, on programming, if they are able to see, if they are able to read a C program, they are able to understand what exactly they are doing. If they have a little bit idea about function calling, function definition, okay, so simple programs and all everybody can understand. So that's why I'm telling this is actually like very important whenever you are choosing any programming language. All these features we have to go through. Okay, still we haven't coming to the conclusion that why again C. C is a high level programming language, right? Why again C? Why we can't use C++ or Java? So let's quickly discuss about it. Okay, so now we can see embedded system are programmed using different type of languages. It can be machine code. Of course, we can't write the machine code your own. You have to write it in either assembly or any high level language, and you have to convert that to machine code. Okay, and we can use any low level language like assembly language. Okay, assembly language also, like if you people are comfortable with the the instruction set. Okay, so using mnemonics we can write the assembly language. You must have seen, right? Move, like one example I'm telling, move a comma b. Okay, so if a and b are the registers, or move a comma r1. Okay, so like this mnemonics we used to write. So this kind of code we can say assembly language code. The problem with the assembly language code, I told, for simple programs and all it's okay. Like even if you're comfortable with the instruction set, we will be able to write the program. But if your program complexity is more, and if you want to call different functions, right, so then this will be like a little bit problem, not little bit, it will be problematic. Okay, so the code size will be bigger, the readability is less. Okay, only the person who know the instruction set or who can understand assembly language, they will only able to program this assembly language. So the cost will be high. Why the cost is high? What can be the reason? So the cost for assembly language programming will be higher. The reason is that, first of all, it's not the cup of tea for every developer, right? Only the person who know about the hardware instruction set, they will be able to write the program. So maybe the resources are less or the developers are less, okay, and even the complexity is more, readability is less. Even though if you are having a problem, it will take more time for the debugging, and if you want to make any changes and all, it's very difficult. So I'm telling the cost and complexity wise, like it is higher compared to the assembly, sorry, it is higher compared to the higher level languages. Okay, and the next thing we can use any high level languages like C, C++, Java, Edge, etc. Okay, so C, as usual, I told C is the dominant language, and still we are going to discuss about C programming used in embedded system. C++, why we can't use C++? Of course, we know that is actually using the object-oriented programming concept. Like OOPS concepts are there in C++. But the problem is that whenever you are writing any program like using C++, so that C++ is having so many like other concepts like maybe virtual functions, okay, error handling, so many things are there in C++, like maybe the OOPS concept, okay. So that is always going to like enhance your code size, okay. So your code size will be more whenever you are writing a program with C++. But still we are using C++ if you want to implement, if you want to use any templates, okay. So the polymorphism, inheritance, these features, if you want, you can use C++, but we are not actually using the advanced concept in C++, okay. So we are writing the C++ program for embedded system, but it is like similar to C, okay. So the same way or the similar way of C programming structure we are using. For that simple applications and all, even we can use C++. Okay. Nowadays, even in embedded system, the C++ language is even that is in high demand. Yeah, of course, somebody is good in C++, of course, they can try. And maybe one example I would like to tell you, like Arduino. Arduino, I think usually everybody is programming nowadays, right? Even kids are starting like their robotics. Okay, so with Arduino programming. So in Arduino programming, we are using embedded C++. Okay, so there we are having the habit of creating the templates, for example, for servo motors and so many other things. The libraries are there and the templates are there. We'll be using all these features over there. So that is actually based on embedded C++. And Java, of course, you can use. The problem with Java, again, the code size will be more. Okay, so the complexity will be more. Earlier, we know, right? Like like maybe the smartphones and all, we were using Java program. Okay, so the for the JVM, the like space it's consuming is more resources we need. So that's the reason even Java we are not using much here. Okay, for embedded programming. And yeah, so application level languages we can use for embedded programming, the Visual Basic, Script, Access, etc. Yeah, so these are the major pillars, or these are the four different ways we can program. Okay, I hope all are clear, right? Machine code, of course, we can't use. The assembly language, I already told you what's the pros and cons for assembly language. And high level languages, we discuss C, C++, Java. And I already discussed why we can't use C++ always, why we can't use Java. Then why we want to use C. So C is a simple and a structured language. Okay, so that is better. We will be choosing C language, right? Now let's discuss about the embedded software development process. Okay, so what is the embedded development process, software development process? As we know, like whenever we are having an embedded system, so that will be a separate controller or that will be a separate like a board. Okay, so maybe a separate IC. Initially, what we will be doing as a normal software engineer, we will be writing the program like in our host machine. Okay, so we'll be writing the code in our host machine. We will compile it. Okay, right, yeah, we will be compiling that, we will be debugging that and everything, all, even possibly if you are having any simulation software, we will simulate it and see whether it's working properly or not. Maybe I'm not very sure whether you people heard about Tinkercad for Arduino. Okay, so you can everything you can do it over there. You can run the code, you can check it, you can test it, everything you can do it in that like online platform. Or maybe you heard about some other simulation software which we can use, Proteus. Okay, for 8051 programming. Okay, even for PIC, we can use Proteus. I couldn't find a better option for STM32, so the ARM controller. So we'll be testing that in with the real hardware. So when we are testing that with the real hardware, we have to be little careful, right? We shouldn't damage the components. We have to be careful about the power supply. Okay, so all these features we have to consider. Yeah. So the software development process we were discussing. So we will be actually having a host machine. So there will be having some development platform, right? So there will be writing the program. So that program, like even while writing the program using the IDE, okay, like using that IDE, I will be able to choose the controller, choose the hardware, what I am going to use. Okay. So it can't be, of course, for x86 machine. It can't be. Okay, I'm telling. For example, even I am writing the program for STM32 like ARM based microcontroller. So like in the kind of ID which I am using in my host machine, I'll be choosing. I'm writing the program for this particular controller. Right. So why we are using that, and like here we will be having like more memory. Okay. So in the host machine we are having more memory and more capable processor. Everything is fine. Okay. Different input output IO ports can be there. Okay. So the capabilities will be different, but still we will be writing the code for host machine and using this tools. What are the tools we are using? Editor. So editors will be the text editor kind of thing where we'll be typing the program. Then we'll be using the compiler. I hope compiler, why we are using compiler, that's clear, right? We'll be compiling the code. Okay, we'll be converting that to machine, like machine language. And even we can use the debugger. Why we are using debugger? For what purpose we'll be using debugger? If you want to debug the code, right? If you have some errors, okay, so that will be checking. Like first of all, we can check the syntax error, everything, so that you can, first of all, let's try to avoid that. Then maybe after that we'll be like moving to the like logical errors. Okay, so logical errors in the sense, if you are having a simulator, you can understand, right? If any logical errors are there, for example, I am just controlling a DC motor with the temperature. For example, if the temperature exceeds then 30 degree, like the DC motor should be on. Maybe the DC motor is actually representing the fan. Okay, so I'll be able to check this with the simulator. I can actually simulate the temperature can be increase or decrease, and accordingly let's see whether the like the DC motor is on or not. Okay, so that is even possible like in the host machine. Okay, once everything is done, then only we are actually dumping the code to the target machine. So target machine means that will be the embedded hardware. Okay, so that embedded hardware that will be having a special purpose. Of course, the target machine, that means the microcontroller, that can't be the that can't be like the host. Okay, because host we discussed, that's general purpose. Like in the host machine, I can install the ID for 8051. I can install the ID for PIC. Okay, so maybe for ARM controller, different IDs I can choose, or even some IDs like will support all like all different devices. Okay, like Keel ID and all that supporting 8051, and Keel is there for like ARM controllers. Okay, so like the host machine is general purpose, but on the other hand, target is very specific. That's for special purpose. And on the target machine, we know like we are having very limited processor memory, like IO devices and all. Okay, so the input output pins will be limited, right? And of course, we'll be having like individual kernel. We'll discuss about RTOS concept for embedded system, why this real-time operating system is required, like for the embedded system. Like normal OS, we know, right? For the PC, we know like we'll be installing any OS like Windows, Linux, okay, or Mac, okay. So these are the general operating system we are using. But for embedded devices, like for advanced embedded devices, even we can implement RTOS, real-time operating system. Both are little bit different. The purpose wise or the application wise, the normal OS and RTOS are different. And here for the target machine, we don't have any like development tools. Like we discussed already, for the host machine, we have the development tools like editor, compiler, debugger, okay, assembler. So many tools are there for the host machine. That's the reason we are preferring, we will be like keeping the ID. Like in ID, maybe most of the things are already included. We don't want to install anything separately. Okay. But on the target machine, we don't have the any development tools like that. So everything will be done from the host machine. Then using the cross compiler. Okay, I'm telling you are using any cross compiler, and after that using like cross compilation will be done by cross compiler, because both are different hardware, right? The host and target. So using the cross compiler, will be generating the machine code for that particular target device. Then we'll be dumping that to the microcontroller or the target device, and that will be performing accordingly.